The enthalpy of formation, which is also known as the heat of formation, is the change in energy that occurs when 1 mole of a compound is formed from its pure elements under standard conditions, which is 1 atmosphere and room temperature. So for example, 1 mole of water is formed from 1 mole of diatomic hydrogen gas and half a mole of oxygen gas. And these naturally exist as gases under standard conditions. So it doesn't take energy to form them. And for example, oxygen gas has an enthalpy of formation of 0. And here you see half a mole of oxygen gas, because these chemical equations are written based on 1 mole being formed from these constituent pure elements. And here is another example of methane being formed from an allotrope of carbon. So graphite is a stable allotrope under standard conditions, and 2 moles of hydrogen gas. And 1 mole of methanol is formed from the following constituent pure elements. So therefore the enthalpy of a reaction under standard conditions can be obtained by subtracting the enthalpies of formation of the reactants from the enthalpies of formation of the products. And these are typically given in tables. The combustion of methane is represented by the following reaction. Find the enthalpy of reaction. So therefore the enthalpy of a reaction, assuming standard conditions, is equal to the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. So for the products, we have 1 CO2 plus 2 H2O and for the reactants, we have a methane, and the enthalpy of formation of oxygen is 0, because it exists naturally as a gas under standard conditions. So using 3 significant figures, we obtain 890 kilojoules per mole. And this is similar to the result we obtained using bond enthalpies.